Today we will start electrostatics. So we have finished the basics, that is vector calculus, so vector analysis. So all these basics are required for understanding electrostatics. So let's see. So electrostatics, as the name says, is a study of stationary electric charges. So the electric charges which are at rest. So about that, if you are studying means that is what we call as electrostatics. So electrostatics is a study of stationary electric charges. I will give you one example of an electrostatic experience which you have in your daily life. When a hard rubber is rubbed on a piece of wool, electrons are transferred from the wool to the rubber. Like, you know that. Also, you take the scale and rub it on your head, rub it on your hair, and you say there is some kind of charge developing. All these are example of static electric charges, that is electrostatic charges. So for example, if you are taking a hard rubber, so this is a hard rubber, and you have the hard rubber, and you have the wool here. So you know that when a hard rubber is rubbed on a piece, electrons are transferred from wool to the rubber. So electrons are transferred. So wool is losing the electron. That means the wool will have a positive charge and the rubber will develop a negative charge because the wool is losing electrons. So that is one practical example of an electrostatic charge. The best way you can explain electrostatic charge to somebody is, so that is between hard rubber and wool. When they are rubbed against each other, there will be loss of electrons. So one will be losing the electron, so it will become a positive charge, and other will be gaining the electron, so that it will become a negative charge. Then what else? Electrostatic. This is actually an introduction only. So electrostatic mainly deals with the interaction between charged particles which are in stationary condition. The same thing which it is given in red color here. And when two charged bodies are separated over a finite distance. Okay, now comes the next point. So electrostatic force will be between two charged particles and they should be separated over a finite distance. Then each body experiences an electric force. So now we are talking about the force between them. Earlier we told that electrostatic charge will be developed when they are rubbed and then they are kept when they are rubbed against each other, and if these two charged particles are kept at a certain distance over a finite distance, then each of the charges, be it the hard rubber or the wool, both of them experience an electric force. Is it clear? Whatever I have explained this first slide, is it clear for everybody? Same thing you have studied in your 9th standard, I think. Clear?
Yes, sir.
Yeah, that's clear. Now, okay, before going to the applications, I want to say, so I told you about electrostatic force. So apart from the electrostatic force, which is the other force a body, a charged body, if there are two charged bodies, there will be electrostatic force between them. Other than the electrostatic force, there is one more force that is acting on all the bodies, not just the charged bodies. Weight body force. What is that force? There will be gravitational force. Apart from the electrostatic force, there will be a gravitational force. So you're talking about the force between two charged particles, right? But the fact is that the gravitational force can be neglected as the mass is very small compared to the charge. Because in electrostatics, we study about point charges. So point charge means the mass will be very less compared to the magnitude of the charge. So we are talking only about the electrostatic force, and gravitational force here we are neglecting. So that's just a concept which I want to share with you. So that's electrostatic force. And now we go on to the applications. So actually in this module, you are studying in detail about all these things. That is force between charged particles, that is the Coulomb's law. Then you study about potential gradient, equipotential surface, electric field intensity. And towards the end, you study capacitance, then energy stored in a capacitor, all these things. So these are all applications of electrostatics. So now let's see in our daily life where we are using electrostatics. So as I told, capacitors. So next semester when you study power system, you study transmission line parameters. So transmission line parameters means resistance, inductance, and capacitors. So capacitors. So നമ്മൾ കാണുന്ന transmission line capacitor ഉണ്ട്. അതാണ് പറയുന്നത്. So transmission line capacitor ഉണ്ട്. So അതൊരു electrostatic application ആണ്. So capacitor ഉള്ള electrostatics in the application you will study in this module. Then capacitor used for power factor improvement. നമുക്കറിയാം power factor should be close to 0.9. So power factor improvement use ചെയ്യാം. So this one you know, the cathode ray oscilloscope which you are using in your lab, it has applications of electrostatic. Then electrostatic precipitator. ഇതെന്ന് പറയുന്നത് electrostatic precipitator ആണ്. This is an electrostatic precipitator. So what happens in electrostatic precipitator is, you know, precipitation means the removal of the dust, unwanted particles and all, right? So it is used to remove the ash and dust particles from the exhaust. So വലിയ factories ലൊക്കെ ഉള്ള exhaust ൽ നമ്മൾ electrostatic precipitator വെക്കും. So it's also an application of electrostatics. Thermal power plants ന്റെ ഒക്കെ exhaust ൽ ash exhaust ൽ അല്ലെങ്കിൽ steam exhaust ൽ നമ്മൾ electrostatic precipitator വെക്കും, and that's an application of electrostatics. Then the xerographic machine, നമ്മൾ photostat എടുക്കാനുള്ള ഉപയോഗിക്കുന്ന machines, അത് മെഷീനും എന്താണ് photocopy എടുക്കുന്നതും it's a application of xerographic machine, electrostatics. Then you know, thunder, clouds and lightning, thunder and lightning. Then corona effect. So I think you might not have seen corona, might not have studied corona effect. So it actually comes in your power system. You will study it later, so I'm not going to explain. So it actually happens when we have high voltage and all. So I'm not explaining here. So just understand these are the applications of electrostatics. So what is electrostatics? So what happens? And then why we are neglecting gravitational force, and then what is the application, and then daily life applications. Is it clear? So electrostatic precipitator and all in detail, there is no need of study. So your syllabus is actually starting with Coloumb slowly, but I'm just giving you an introduction. So is it clear? So whatever I have explained, is it clear?
Yes, sir.
Okay. Okay, now we will start with Coulomb's law. So Coulomb's law also you might have studied, because I remember studying it in 11th standard, I guess. So your Kerala engineering entrance also has a very good weightage for this Coulomb's law and its numerical problem and all. So I think most of you might be familiar, but still I will go in detail only. So Coulomb's law before going to Coulomb's law, I want to share some more things. So Coulomb's law actually deals with, I already told you, deals with the interaction of point charges. So that's why the mass we are neglecting. So deals with the interaction of point charges. So then what is a point charge? A point charge has a definition. A point charge is the one whose maximum dimension, please write down along with me, the maximum dimension, a point charge is that type of charge whose maximum dimension is very small in comparison with any other length referred. ഇപ്പം നമ്മളൊരു Coulomb's law ഒരു particular case എടുത്തു കഴിഞ്ഞാൽ, ഇപ്പം we can talk about the distance between the two charges, അല്ലെങ്കിൽ distance at that much instance. When whatever be the dimension, any other dimension mentioned, അപ്പം ആ particular chargeന്റെ maximum dimension എന്ന് പറയുന്നത് ആ നമ്മളൊരു particular പ്രോബ്ലത്തിന്റെ കേസ് എടുത്തു കഴിഞ്ഞാൽ, I mean numerical problem എടുത്തു കഴിഞ്ഞാൽ, whatever be the other dimension mentioned in that, ഇതിന്റെ ഈ പോയിന്റ് ചാർജ് ഡയമെൻഷൻ പറയുന്നത് വളരെ ചെറുതായിരിക്കും. സോ ദാറ്റ് മീൻസ് എ പോയിന്റ് ചാർജ്, ഒരു പോയിന്റ്, ദാറ്റ്സ് ഓൾ, നത്തിങ് മോർ ടു തിങ്ക് അബൌട്ട് ദാറ്റ്. സോ വളരെ ചെറിയ ഡയമെൻഷൻ ആയതുകൊണ്ടാണ് നമ്മൾ അതിന്റെ ഡയമെൻഷൻ, അതിന്റെ മാസം എല്ലാം നമ്മൾ നെഗ്ലക്ട് ചെയ്തേക്കാണ്. സോ ദാറ്റ് ഈസ് പോയിന്റ് ചാർജ്. And the Coulomb's law, some history behind that. Coulomb's law was found out in 1785 by Charles Augustin de Coulomb. Charles D. Coloumb. So this was found out in 1785. Okay, so now let's see what it states. So Coulomb's law states that the magnitude of the electrostatic force. So now you know what is electrostatic force. So depending upon whether it is whether two charges are positive or two charges are negative, that is same charge or unlike charges, there will be force of attraction as well as force of repulsion. You know that. So force of attraction or repulsion between point charges. So point charge also what it is, you know, it is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So Coulomb's law states that the magnitude of the electrostatic force of attraction or repulsion between 2 point charges is directly proportional to the product of the magnitude of the charges. It is not just the product of the charges, it is the product of magnitude of the charges and inversely proportional to the square of the distance between them. So mathematically what all we can write? Force is proportional to Q1, Q2 as well as the force is proportional to 1 by d square if d is the distance between the two charges. So, sorry. So now we will represent it like diagrammatically also. I'll just represent and show you. So we have one charge Q here. So it's a plus Q, and you have another charge plus Q here, and it is and we have a distance. So d is the distance between them. So you know that I think from your school days itself, you are studying this. Like charges repel each other. So like charges repel each other, and unlike charges attract each other. Unlike charges attract. So this concept is required because when you solve a numerical problem, finally you need to you need to write whether the force is attractive or repulsive. Also, you find out the magnitude, you will apply Coulomb's law, and then finally you need to write whether it is attractive or repulsive. Also, this concept is required. Okay, so moving ahead, I will just change the color. So our final, so this is Q1 and this is Q2. So F is proportional to Q1, Q2 is one finding, and the same F is proportional to 1 by d square. So one more time I will just say Coulomb's law states that the force between 2 point charges. So when I am saying you just see and understand this figure. Coulomb's law states that the force between 2 point charges separated in free space or vacuum. So that time I didn't mention that it can be in free space as well as vacuum by a distance which is large compared to their size. So that's why this point charge word ഒഴിവാക്കിയിട്ടാണ് ഈ ഒരു sentence by a distance which is large compared to their size. അതായത് ആ point charge ന്റെ size ആ ചാർജിന്റെ സൈസിനേക്കാളും വലിയൊരു distance. അത് തന്നെയാണ്. Then only we say it's a point charge. That is proportional to the charge on each and inversely proportional to the square of the distance between them and is directed along the line joining the two charges. So here statement കുറച്ചുകൂടി explanation. So I'll just write down Coulomb's law states that, please write down along with me, that the force between 2 point charges, the force between 2 point charges separated in free space or vacuum by a distance which is large compared to their size is proportional to the charge on each and inversely proportional to the square of the distance between them and is directed along the line joining the two charges. So you apart from the definition statement which I gave in the last slide, so you some extra points are there. So it should be in free space and vacuum. So here it is written in it is directly proportional to the charge on each. So F is proportional to Q1 as well as F is proportional to Q2, and it is proportional to the product of the two charges. So it's same only, and inversely proportional to the square of the distance between. So it's proportional to the product of two charges as well as it is proportional. Q1 and Q2 each proportional. So correct statement, this is what you should write in your exam as the statement. So this is just for your further understanding. So if force it will be along the line joining two. So Q1, Q2 are line joining the direction. Repelling attracting depends upon whether both are positive or one is positive and one is negative. That's it. Clear or not?
Clear now.
Okay, Coulomb's law. Okay, now we'll see. Now I told you the direction is from Q1 to Q2, right? So direction means, so now we are going to talk about vectors. So Q1 is here and you have, this is Q1 and you have Q2 here. So Q1 and Q2 is in space. So now we need to find the position vector, right? So you know how to write the position vector. So R will be the position vector here. Let it be R1. And R2 is the position vector here. So let it be R2. So then Q1, Q2 and distance vector and what will be that? The unit vector it will be A12 alle. A12 alle. That is vector R2 minus vector R1 divided by modulus of vector R2 minus vector R1. A12 are you able to, are you following? Are you able to recollect? Okay. So you know the A12 will be, what will be A12? A12. So all these things are required. Vector R2 minus vector R1 divided by modulus of R2 minus modulus of vector R2 minus vector R1. So that's A12. So these things you already studied. So now what will be F when we consider the direction also, then F will be equal to F. The vector F is proportional to Q1 Q2 by D square. So that's the statement which Coloumb made. So it will be F is equal to, so proportionality is removed by a constant K into Q1 Q2 by D square along the direction. So along the line joining charges 1 and 2. So that is A12, the unit vector. And depending upon the nature of Q1 and Q2, force will be repulsive or attractive. Depending upon nature of Q1 and Q2, force will be attractive or repulsive. So you know this also. So now we see what is K and all. So we'll move ahead. So this is the basic equation. So this is the equation that you will be using throughout your EMT or throughout your engineering life. So this is the Coulomb's law equation. And now and let's see. So D is the distance between them. Distance between the charges. And what is K? K is equal to 1 by 4 pi epsilon 0. That is a proportionality constant, and epsilon 0 is equal to permittivity of free space. So epsilon 0 is the permittivity of free space is equal to 8.854 into 10 raised to minus 12 unit is farad per meter. And this 8.854 10 raised to minus 12 can also be replaced by 1 by 36 pi into 10 raised to 9. The calculations is epsilon 1 by 4 epsilon 1 by 4 pi epsilon 8 epsilon 8.854 calculation was complicated out. So it can also be replaced by 1 by 4 1 by 36 pi 10 raised to minus 9. When you do one or two problems, it will be clear. So that is about F, and already I told you about unit vector and all. So A12 എന്ന് പറയുന്നത് എന്തായിരിക്കും ഈ R2 minus R1 എന്ന് പറഞ്ഞാൽ എന്താണ്? That is R12 only, right? R12 is equal to R2 minus R1. Already we have studied. So A12 we can write it as R12 divided by modulus of R12. Same thing. So I already explained earlier. So what will be force? Force F is equal to Q1 Q2 divided by 4 pi epsilon 0 into R12 square into, we need the vector also, direction also, R12 divided by modulus of R12, vector F. So E R12 me R12 same തന്നെയാണ്. So നമുക്ക് R12 cube തന്നെ എടുക്കാം. So this is Coulomb's law in complete direction. Problem ചെയ്യുമ്പോൾ നമുക്ക് ഈ ഒരു കാരണം problem ചെയ്യുമ്പോൾ നമ്മൾ യൂണിറ്റ് വെക്ടർ കണ്ടുപിടിക്കണം. അതായത് vector R12 divided by mod of R12. So this mod of R12 is same as this so R12 cube, same only. And 1 by 4 pi epsilon 0 is 8.85 raised to minus 1 or 1 by 36 pi, so depending upon whichever is comfortable. So since you are using a calculator, both the same for you only, so same thing. So is it clear? What is Coulomb's law? Is it clear?
Yes, sir.
Okay, so now we'll do one problem, one numerical problem we'll do, and we can wind up. So just write down the question along with me. I'll just stop the recording. The question: 2 microcoulomb positive charge at 3 minus 2 4 and 5 microcoulomb negative charge just at 1 minus 4 2. So P1 P2, and we need to find out the force. So we'll just write. We'll just draw the figure. So this is Q1. Just change the color. So this is Q1, which is 2 microcoulomb, and it is at 3 minus 2 minus 4. And this is Q2, which is minus 5 microcoulomb, which is at 1 minus 4 2, and A12 is the direction along which the force is acting, it is happening, where attractive or repulsive. And this is the distance, right? Mod R12 is the distance between them. That is D. So everybody, did everybody understood? So this is P1 and this is P2. We have written all the given data in the question. Is it clear for everybody? Any confusion whether why we wrote R12 here, why we wrote A12 here? Is it clear for everybody? A12 shows the direction. Is it clear? Okay. Okay, so now we will move on to section A. Section A. So we need to, so first of all, we need to find R12, right? R12 will be R2 minus R1. So just find it out. We already done these exercises. 1, 4, minus 2, minus 3, minus 2, minus 4. So how much it will be? 3 minus 1. So minus 2ax minus minus 2 minus of minus 4. So it will be 2ay plus 6az, right? 1 minus 3 minus 4 plus 2 and 2 plus 4. So 6az. Clear or not? Nothing to be clear, right? So now you find the modulus. So modulus will be root of. So now you might understood how much important is the basics. Root of minus 2 square plus 6 square is equal to 6.633. And now just directly substitute and find out the force. So force F2. So negative charge in the find the force on the negative charge. So negative charge force normal for the charge F1 and this will be F2. So we are given it taking it as F2. F2 is equal to Q1 Q2 divided by 4 pi epsilon 0 into mod of R12 the whole square into the directional vector. Vector R12 divided by mod of R12. So all these things you have it here. So nothing more to substitute. Vector R12 is here. The modulus of R12 is here. So and the cube. So everything is given. So 2 into 10 raised to minus 3 into minus 5 into 10 raised to minus 6 divided by 4 pi epsilon 0 into 6.633 the whole square into the vector here. We don't have space, but I'll write 2ax minus 2ay plus 6az divided by 6.633. So I'll just write down the final answer. You do it on your calculator. So you people are required to do and understand this thing. So if you're not getting means ask me in the next class. So this is direct substitution. 6ax plus 0.616ay minus 1.84. So if anybody don't know how to do this in calculator quickly means you just try once and then ask me. Okay. So this is just direct multiplication. This is not complex multiplication or nothing. Just you find out what is the product, all these products, and then directly multiply with each of the vector components along with ax, ay, and az, and you will get the answer. Then the next question is, what is the magnitude of the force on the charge at P1? So magnitude of the force endana? Idana force, magnitude endana? It will be root of, and the magnitude. What will be the magnitude? So this is the force F2. What will be magnitude of F2? And there you
root
of 0.616 all square plus 0.616 all plus minus 1.848 all square, and the answer will be 2.043. What will be the unit?
Newton.
Newton.
Coulomb.
Newton. Charge means force means Newton. Okay. So I hope it's clear for everybody.